welcome to Tuesday's edition of Cracking the Cryptic, where I've just been sent through this puzzle to have a look at, and rather daunting it looks too. It's called Killer Ambiguity, and it's by Abid Hawilla. Now, Abid is a fabulous constructor of Sudoku puzzles, but he seems to have been incredibly mean to me today because, look, there are absolutely no digits in this puzzle at all. There are quite a lot of cages, but unfortunately we don't actually know the nature of these cages because there is ambiguity. So this could be a very long video, a very, very long video. I've no doubt it'll be a brilliant puzzle, but at this moment I'm feeling slightly daunted at the mere prospect of having a try at this. I'll read you the rules in just a second. An appeal first. Some of you, I'm sure, would enjoy the extra content we put over on Patreon each month. There's lots of it. It's a couple of bucks a month only, and you get to join basically the best Sudoku club on earth. And in fact, a pretty good cryptic crossword club as well, because today Mark has released a new video where he solves 3 crossword puzzles, no less. There is a solve of a New York Times Friday crossword, a solve of Matt Gaffney's meta puzzle from a couple of Fridays ago, and then also Mark solved in the same video the listener crossword. Now, the listener is the hardest regularly published crossword in Britain, and 4 times a year it does a numerical puzzle, and I think Mark had a go at that too. So all sorts going on Patreon at the moment, and we have 1 or 2 rather cool surprises for you coming up in the coming days as well. Anyway, all that said and done, let's get on with Killer Ambiguity. Here are the rules. Normal Sudoku rules apply. In each cage, at least one of the following conditions must apply. The sum of the digits is a square number, i.e. 1, 4, 9, 16, 25, 36. Presumably that's because, yes, okay, that's because we can't get as high as 49 in a cage, because presumably we can't repeat digits in cages. So yeah, even a 9-cell cage would, because of the secret, which is something I only tell my very favourite people, but of course if you're watching this video you're very much one of those people. But the highest number you could ever, or the highest sum a cage in a Sudoku could ever have, if the digits in that cage have to be different, is 45, because that's the sum of the digits 1 to 9. But the rules don't stop there. So either each of the cages is adding up to a square number, and or the sum of the even digits equals the sum of the odd digits in the cage. Now those two things are quite different, aren't they? So let me just think about this. I'm just going to think about this 3-cell cage here. So either this sums to a square number, and it's 3 cells large, so it can't sum up to 1 or 4. So it would have to be 9, 16. It couldn't actually be 25, because the 3 highest digits you could put in the cage would be 7, 8, and 9. So if it was square, it would add up to 9 or 16. But if it was one of the other type, the sum of its even digits would equal the sum of its odd digits. Right, and I can understand how that would, so that could be a 6, for example. Whoops. That could be a 1, and that could be, 1, and that could be a 5. That would be a legitimate way of filling this cage. Now, if that was an 8, that could change to being a 3, or I suppose it could be 1 and 7. So, right, good grief. Anyway, do have a go. The way to play is to click the link under the video as usual. And now I get to play. Let's get cracking. Now, what can I see? I can see we've got one big cage in the grid, which is a 7-cell cage. So let's have a think about this 7-cell cage. What is this telling us about its nature? We know that if it was a 9-cell cage, then the digits in it would sum to 45. The triangular number for 7 is 28. Okay, so this cage cannot sum to 25 because 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 is 28. So it has to add up to more than 20, or 28 or more, and the next highest square would be 36. So if this is a square cage, it has to add up to 36, and it would therefore be missing 2 digits that sum up to 9, because 45 minus 36 is, I think, 9. But there is no requirement for it to be a square cage, at least I don't think there is. So it could be one of these cages where its even digits add up to the same number as its odd digits. So you could have no, you couldn't have 3 odd digits, could you? No, actually, that's a good thought. You can't have 3 odd digits adding up to 4 even digits, because that won't work from a parity perspective. So if... yeah, okay, that's something I should have understood immediately, but didn't. So if this is one of these cages where the odds and the evens add up to the same number, the sum of even numbers is always even. Therefore, we need an even number of odd numbers in the cage in order to add up, make sure the odd numbers add up to an even number, if you see what I mean. So this cage would either have no, it wouldn't have 2 odd numbers, because then you'd have to have 5 even numbers in the cage, and there are not 5 different even numbers between 1 and 9 inclusive. There's only 2, 4, 6 and 8. So if this was one of these parity cages, it would actually have to have 4 odd digits in it, because it couldn't have 6 odd digits, because again there aren't 6 odd digits between 1 and 9. So either this is a nightmare though, because what we're now learning is that either this cage sums to 36, which means it's missing 2 numbers that add up to 9, but the problem is there are 4 different ways of making 2 numbers add up to 9, 1, 8, 2, 7, 3, 6 and 4, 5, or it's a parity cage and all we know about it is that 4 of its numbers are odd and 3 of its numbers are even. That doesn't seem to be very useful. Right. Okay, but hang on a minute. I want to look at that cage, I think. Yeah, that's a bit interesting to me and a bit suspicious. The problem is, even though I think this is really interesting, I can't see what it means at all. This cage, let's look at this digit in fact. Let's imagine that digit is a 1. Hopefully it's fairly obvious that now you can't put 1 in the orange cells at all, because the 1 sees these in its row and it sees those in its box. So this digit, and the same is true of this digit, don't repeat or can't appear in the orange cells. And that means that we can get rid of that, highlight those 2 squares, and we can say that that is an extra region of the Sudoku. There is a green and orange region of the Sudoku in the top right corner, which is 9 different digits. Because obviously these orange ones are 7 different digits and the green can't repeat in the orange. So now this domino has now become interesting all of a sudden, because now that domino has to appear in orange somewhere, because it doesn't appear in green. And the only place that the blue digits can appear in orange is in those squares. Which means blue is over here. Whoa, this is interesting. So now in the top row of the puzzle, we've got 4 effective cages, because this cage is the same as this cage. Ah, that's it. Right. Here is a good question. I've finally come up with a good question after 10 minutes. What is the nature of a domino? I realise sometimes I say strange things on the channel, but what is the nature of a domino in this puzzle? That is a good question. Because what it cannot be is one of the funny parity cages. Because if it was a parity cage, it would have to have an odd and an even number in it that had the same total, and that won't work. So if this was an odd number and this was an even number, clearly they can't add up to the same number. That's impossible. So every domino in this puzzle is a square number. Ah, right. Right, so that means I'm very tempted actually to highlight every domino in this puzzle. That one's is that a domino? Yes, that is a domino. That's a domino. That's a domino. That's a domino, 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 nori nori, that's a domino, that's a domino. This is a domino, this is a domino, but also we've got this funny virtual domino in those two cells. Let me just highlight, what colour shall I use? Yellow? I'm not sure whether I should get rid of my orange highlighting. I think the orange highlighting can be got rid of. Oh, so maybe I should change, for colourblind friendliness, I should change yellow to orange. Yeah, okay, now those are blue, weren't they? So now, actually I'm going to change the blue as well. Sorry, because I'm not normally, when I do, when we do puzzles that involve two types of shading, the best colourblind friendly colours are orange and blue in our palette. Now I need a colour to represent cages that are adding up to square numbers, and I need a colour to represent cages that are adding up to parity numbers. So I should use blue for the other type of cage. So that cage is orange, and this is sort of a virtual orange, which I'll make yellow. And so now I've got to think of a few things to explore. Not least, are there other sizes of cage in this puzzle that are forced to be, you know, one type or another? No, I looked at the triominoes and the example, so I don't think that's actually going to help me. A 4-cell cage. No, a 4-cell cage could definitely be 1, 5 and 2, 4, couldn't it? That would work. Yeah, the odds and the evens would both add up to 6. Or it could be just some numbers that add up to, I don't know, 25 or something, and be a square cage. No, okay, so I think it's only the dominoes, probably, that we can do anything with. But let's come back to the top row then, because now in the top row I've got 4 cages that are all, well, 4 effective cages, bearing in mind the yellow is the same as this cage, which is a square cage. So I've got 4 cages that add up to square numbers. Now the total for the row is 45. So what does that mean? Does that mean we have to have a 16 cage as one of these cages? If we don't have a 16 cage, we could have 4, 9, 30. No, that's annoying. Right, so we could have no 16 cage in those 4 cages, and all of the cages adding up to 9, and that would work because this square could be a 9. Now, the only other options, therefore, are going to be that one of these cages is a 16 cage. And we can't have 2 16 cages because the way you make 16 is with a 7 and a 9. And there's not another way of doing it because you can't obviously do that. That will not work. So if one of these if this is a 7-9 cage, 16, then we've got 3 more cages So 3 9s are 27 and 16 is 43. That would make this a 2. Is there anything wrong with that? So that would be a 16 here, or 16 here, and then 3 9s. Or you could have a 16, 2 9s, which would be 18, 16, 34, 34, and then this cage could be a 4 cage, and that would make this a 7. Now we can't have 2 4 cages for the same reason we can't have 2 16 cages, because the only way of making 4 is with a 1 3 pair. So I think this cell we now limited it to 3 different possibilities. It's a 2, it's a 7, or it's a 9. And that depends on whether one of these is a 7. Now hang on. If one of them's a 7 9, does that knock 7 and 9 out of this? Hang on. So if that's 7 and 9, what were we saying? So if we've got 7, if we have a 16 cage, oh no, okay, right. If we don't have a 16 cage, we've got 4 9s and a 9 here, so that survives. If we do have a 16 cage, we've either got 3 9s, 3 9 cages, and that's a 2, or we've got 2 9 cages, and that's a 4. And that puts a 7 here, which doesn't write. This is very interesting. So now I have worked out that there could be a 16 cage, but if there's a 16 cage in these 4 dominoes, there are 3 9 cages. There is no 4 cage in this line, and that is not a 7. Because if it is a 7, it's going to clash with the 7 9. Now obviously this 7 9 might be here, here, or here, or it might not even be anywhere, because these could all 4 of these cages could add up to 9. But this is a 2 or a 9 now. Now, what can we do with that? Can we use the fact that that's $16? Yes, okay, here is a small point. This is not a 16 cage, is it? Because if that was a 16 cage, because this is an extra region of the puzzle, because that is a set of the digits 1 to 9, if that's a 16, the remainder of this this funny extra region would have to add up to 29. Now 29 is odd, and it therefore, well, 29 is clearly not a square number, but it also can't be a parity number, because we know in a parity number we're always adding up the evens to an even. So the odds are adding to an even, so the overall sum of the cage has got to be even, not 29. So this is not 29, even though it looks like it's 29 because it seems I've labelled it 29. That's just saying that cell is a 2 or a 9. So this domino, oh, bobbins, I didn't mean to do that. What I want to say is that this domino adds up. It adds up to 9, which means if I was pencil mark, I would do this. No, I'm not doing that. I'm just going to try and remember it. That adds up to 9. So that adds up to 9. Does that tell me anything about this one? So if that adds up to 9, this one, if that adds up to 9 as well, that would be... No, that doesn't do anything. Oh, I suppose I should check that 9 works. Oh, 9 does work. Well, that's a relief. Okay, that's a relief, because I was suddenly thinking, gosh, I've worked out this wasn't 16, but if it couldn't be 9 either, then something I've done logically would have been incorrect. But if this does add up to 9, and I think it does, these would add up to 36, and 36 is definitely a square. But actually, this could still be a parity cage, but at least it has options. Right. So So this cage adds up to 9. I don't know, or at least I don't think I know, what any of these 3 cages add up to. And it's weird, you can do all of this without, I haven't even looked at the rest of the grid really, except to highlight cages. So let's have a look at, yes, okay, well we can do exactly the same logic on this box, can't we? That's beautiful. Right, so I think the whole theme here seems to be dominoes that add up to square numbers, because those 4 squares all have to add up to, it's the same logic as row 1. In row 1 we've got 4 dominoes that we know add up to square numbers. In box 4 I've got 4 dominoes that we know add up to square numbers. So this must be a 2 or a 9 again, just like that one. But this is better. This is better because now, rather than this one, which is sort of floating in a funny cage, this one is floating in a small cage that adds up to a square number. So if this is a 2, this can't be a 2, because although 2 plus 2 equals 4, that would repeat the 2, so it would have to be a 7. And if that's a 9, that still has to be a 7. So we've got a digit. That's a 7. Because this cage adds up to a square, it either adds up to 9 or 16. That feels right, doesn't it? I think that's good. So now in the top row, that can't be a 16 cage. Oh, this is right. This is really interesting. This is really interesting because remember these squares are the ones that transpose there. So in this row, if there is a cage that adds up to 16, it's not this one, it's not this one, and it's not this one, because this 7 sees that domino, so this can't be a 7-9 pair. So the only way that the top row has a 16 cages in it is if there's a 7 there, and that's a 9. And that would make this a 2. And that would make that a 2. And that would put 2 in this cage here by Sudoku. And that cage would add up to 9. 9, 18, 25, 20. This cage would have a 2 in it and would add up to 20, which is not a square number. So this would have to be a parity cage, which means it's got to have 2 odd numbers in it. Hang on, I'm getting confused now. Because then it's got to have 3 even numbers in it, and 3 even numbers are going to add up to more than the... Hang on. Right, let's just do this slowly, because I think there's a problem here. If this is a 9-7 pair, we know every other cage and virtual cage in row 1 adds up to 9. So this adds up to 9. 9 plus 9 is 18, plus 7 is 25. The whole box adds to 45, so that adds up to 20, which is not a square. So the even digits in this cage add up to 10, and the odd digits in this cage add up to 10, and the only odd digits available are 1, 3, and 5, and there is no combination of those that adds up to 10. So that doesn't work. It just mathematically it fails. So this is not 9-7, which means, hang on, I need to go back, because that tells us, well, no, we know that's a 7, but now we know that there's no 16 cage in the top row, so these 4 cages all add up to 9, and if they all add up to 9, that's a 9. 2 digits. Now there's a 9 in this cage, look. This adds up to 9. This adds up to 9. This adds up to 9. And that adds up to 9, doesn't it? We worked out that added up to 9 because we worked out that this had to add to a square, had to be a square number or even in total. So we know that this adds up to 36, and we know this adds up to 9. So these two cages add up to 18, which means those cells add up to 27. No, okay, which means those cells add up to 18. Right, okay. Not sure. Oh, well, I've not looked at this one at all, but this one's the same as that one. So this is this is beautiful. Right, sorry, I've got distracted. I was just focusing so hard on the top of the grid and then on this bit. I didn't spot this, which is the same as this. It's symmetrical to it around this vertical axis. So these 4 cells have to be square numbers, which makes this square a 2 or a 9 using all the logic we did earlier. It now sees a 9, so that's a 2 and that's a 9. And that means... well, that means this square's a 7 again, because this domino has to add up to a square number, and now the only square number it can get to without repeating a digit is 9. So this is a 7. 7 is now... oh, this is gorgeous. Right, where's 7 in this box? Remember, these two squares need to retain their yellowness, really, because they're the same as those two. So 7 can't go there or there by Sudoku, but it also, because it can be in neither of these squares, it can't be there. So 7 is in one of 3 positions. Now, oh no, that's wrong. I was about to say the 7 has to go with a 2 because we know in the top row there's no 16 cage. And for some reason I was transposing that there and saying that had to be a 7 and a 2 if there was a 7 in here, but that's not right. This could be a 16 cage, couldn't it? I think. Right. So what on earth do we do now? I feel like we've made a massive amount of progress by getting 5 digits in the grid. So if this is a 7, then this is a 2. So if that's, let me just look at that actually. If that's a 7, that's a 2, because we know this cage is adding up to 9. Now in this box I've got 9 here and 9 there, that's 18, which means that's the wrong count, isn't it? I feel like I might be going mad here, but I don't see how that works. If that's 7, that's definitely 2. I've got 9 there. I know that cage adds up to 9, 18. That's 27 in these cells, and that's not even, and it's not a square number, so that's wrong. So I think that this is not 7, and there's a 7 in here, which means there's a 7 up here, and that's beautiful because we know that 7 goes with 2 because it can't go with 9. This is so clever, honestly. Now there's a 2 down here by Sudoku. Now, do we know what the nature of this is then? It's very annoying, but I don't think we do. We know it's a square domino, and we know it's got a 7 in it, but how do we know whether it's 2, 7 or 7, 9? Both of which seem to work. They just throw a digit down here. It feels like we should be able to work that out, doesn't it? What about this box now then? We've got a 7 in it and 2 triominoes. Now do we know... No, this is horrible. It's very difficult to know what to do with a triomino because a triomino can be of either type. So these this is very weird. This is very weird indeed. I know what we can do. Right, I can limit this digit. And that's because this cage here can't have that many different values, can it? Oh no, it can. No, well, it's true. If it's a square number, it really can't. Let's work that out. So if this is square, it's got 5 cells in it. Can it be 16? Yes. 1, 2, 3, 4, 6. Is there any reason that can't be 1, 2, 3, 4, 6? Oh no, it's got a 9 in it. Yes, that's a very good reason. It's not that. So it's not 16. So it's either 25 or 36. If it's 36, that's too many. You can't make 5 cells add up to 36. So if it's square, it adds up to 25. Okay, so 25 plus 7 is 32, plus 9, we know that's a 9 cage, is 41. This is a 4. And that would be a 5, because this cage adds up to 9. So one option is that this is 4 and this is 5. But the thing I failed to realise when I was thinking about this before is there's no reason that this cage, I'm going to highlight it because I keep having to highlight it over and over again, that the green cage, there's no reason the green cage is a square number. It could be a parity number, which means it's even. And there are a lot of even numbers it could be, even given the fact it's got a 9 in it. Let me just think about that. It's got a 9 and a 2 in it. I've got to make sure, if it's a parity, it's got to have 2 odd digits in it. The other odd digit is not 7. So it could be 9 and 5, which would be 14. So the cage overall would add to 28 then. 14 could be 8, 4 and 2. Yeah, okay, so that would work. So if this was 28, 35, 44, and this would be a 1, and this would be an 8. But this doesn't have to be 9 and 5. It could be 9 and 3, probably. 9 and 3 is 12. Yeah, we can make 12 by using 2, 4, and 6. So this cage would add to 24. 24 and 16 is 40. That would make this a 5 and this a 4. Now, what about 9 and 1? If this was 9 and 1, it doesn't work. And the reason it doesn't work is you can't make 3 different even numbers only add up to 10, because 2, 4, and 6 add up to 12. Right. So there aren't a whole world of options here. There are not a whole world of options. So this is 1, 4, or 5, and this is 4, 5, or 8. Okay. How do we improve on that then? So if this is 4, 5, do we know what, we don't know what this one is? Oh, this is so difficult. It really is. Okay, so let's see if there's any restriction on the value of those 4 cells. So if this is 4, we know that's 9, so that's 13 there, but this has 2 options. It could be, oh, this is getting ridiculous. It's going to be, because for each of these options, there's 2 options here. So we've got sort of 6 different iterations of this to work through. I will do that if I have to, but I'm not so sure there's not going to be a better way of doing this. is there another way? Is there another way we can prove? Because if I can prove this is not a parity exercise and is a square number, then I know what this digit is, because it only had one option in that case. What are we doing with this? We're always adding 2 odd numbers together, and we're adding 3 even numbers together. Oh, well, okay, I've just realised something about this cage, which I hadn't realised before, and that's that the sum of this cage is always divisible by 4. And that's because, if you think about what we're doing in this cage, we know that the evens add to an even number. An even number, by definition, is divisible by 2, so it can be expressed as 2x. So the even numbers in this cage could be expressed as 2x, which means that odd numbers in the cage could be expressed as 2x, which means that the sum of the cage is 4x and it's divisible by 4. So this cage, I don't know if this takes us forward because I think we worked out the options for it anyway, but any parity cage in this puzzle is divisible by 4 is what I think we're now appreciating. We worked out that because this had to have a 9, because this adds up to at least 19, it could be 20. No, it can't be 20 because it has 3 evens. That was the problem. So it's either 24 or 28. Okay, I'm struggling here, aren't I? So if this is 24, let's just think about that. If it's 24, we know that the other odd digit in it is a 3. We know that the even digits in it are then 2, 4 and 6. So the only option for that is 1 and 8, isn't it? Or am I going mad? And this has to be a 5. Let me just check the maths on that then. 9. So if this is 24, yes, 24, 16, that's a 5. This becomes a 1, 8 pair. Now, option 2 is that this adds to 28, which means we've got 9 and 5 in there. 28. This is now 1, so this is definitely not 1, 8 in that situation. In here we'd have 9, 5, and then we're missing a 14, so we're missing a 6 out of the evens, so the 6 has to go in there. Okay, so this has to be a 3, 6 pair. But the whole problem here is that this could very well be summing to 25, and if it's summing to 25, this is 7. If it's summing to 25, do we actually know what's in it at all? I don't know. 25 plus 16 is, so that's 41. This is a 4 in that instance. 25. So this now can't be 2, 7. Oh, all right. So it's always from those digits then. I might not know what's in it, but in that case where this is adding up to 25, because this is a 4 and this is a 7, this can't be 4, 5 or 2, 7. So it's always 1, 3, or so always either 1, 8 or 3, 6. So we know there's a 2 in here. So I don't know anything else. I can't lock any other digit other than 2 or 9 into that cage. This is very difficult. I'm sorry about this. I'm sure that there is a way we can do this, but I'm not understanding what it is. So I know there's a 7 in here. 9, I don't know where the 9 is in this box. I know that's not a 9, I suppose. Is that going to help me? Is there a way that we know I can get more of a hand? I suppose this is what I'm going to have to do, I think. I think I'm going to have to work out what the possible values of this are. I know that's 9, don't I? So I know these 4 cells together are either adding up to 18 or 25. Ah, okay. Okay, that's a little bit interesting, isn't it? Because that means, yes, okay. No, actually, no, it's still okay. Ah, this is very annoying. Right, so if these add up to 25, which they might do if this is a 7-9 pair, if those add up to 25, this one can't be a 5 now, because that's going to make these add up to 15, which is neither a square number nor a number divisible by 4. 25. So if this was an 8, on the other hand, that works. This could be a 12. If this is a 4, 25, 29, 16, that's even better. Oh, you rotten thing. What about if this, right, let's try it the other way around. If these add up to, so if these are both 9, if these are 18s, so now this can't be even, can it? Oh no, it could be even if the square works and it's odd. Oh god. If this is 8, so this is 18, and this is, so if that's a 4, we've got 22. 23 will not work. That's definitely not square. Okay, so if we've got 18, 26, 19 also doesn't work. So the only thing that will work if these add up to 18 is with a 5 here, which is 22 in here. 22 in there. So if these are 22, but how is that helping me? That's my question to the world. How is it helping me? 22 would imply we've got 11. Oh no, hang on, 22. 22 is not divisible by 4. Oh, Simon, that's the point. Right, good grief. Okay, is that... I was thinking, I just forgot the times 4 thing, and I was thinking of 11. Oh, I can make 11, but of course I can't make 2 even digits add up to 11. So maybe this is it. Right, okay, come on, wake up, Simon. So now we've got... So if this is 18... the contention is that nothing here works, which would force this to be a 7-9 pair, which would at least be a little bit interesting. So let's double check it. 18 here. If this is a 4, 22, this is 23. That just doesn't work. If this is a 5, 23, 22 here, that doesn't work. It's not divisible by 4. And if this is 8, that just doesn't work either. It's 19, isn't it? 18, 26, 19. No, that's rubbish. Right, so now we can say with certainty that this domino is a 7-9 domino, because we need these to add up to 25. But have we actually taken ourselves forward? Well, now I know those aren't 9s. I can see that. I know. I still don't think it's really done. Well, if we know they're 25, I know. So if that's a 4, this is 16, which could be either way round, 4, 5. we wouldn't know what this is at all, I don't think. If that's right, we've got 25 here, haven't we? So if this is 5, oh, that doesn't work at all now. Right, that's a little point. Yeah, we can take 5 out as an option from this square, because if this is, and it is, if those 4 squares add up to 25, 25 plus 5 is 30, and that means those are 15. 15 is not square and it's not divisible by 4, so this is not 5. So this is not 4. So 4 in this row now, in the top row, is in one of those 3 squares. So 4 is not down here. Is that helpful? So if 4 was here, this would be a 4-5 pair. 25, 33, 12. Oh, that is helpful. It's helpful. Okay, this is just so, it's far too clever for me, this puzzle. That doesn't work because, right, if we know these 4 squares add up to 25. If that's an 8, we get to 33. That means these 4 squares have to add up to 12, which means that the even numbers, and there will be 2 of them in this foursome, add up to 6. And that means they're 2 and 4, which they now can't be because of where 4 goes in the top row. That's beautiful. Fair enough. So that is therefore not 8, which means it's 4, which means that's 5. These squares are something else then. So these squares are whatever this isn't. So this is 1, 8 or 3, 6. And now we know these squares. So we know this is a 16 cage, which means that even numbers in it add up to 8. And they don't include 4, so they must be 2 and 6. Which means that's not 3 and 6, surely. I mean, I don't know if I've ever done a puzzle that's made me second guess myself so much, but I think that's right. So that means, if that's right, that means this is a 1-8 pair. And the odd numbers in here are 3 and 5. And that feels like heroic levels of progress. So now let's look at this. We've got 1, 2, 4, 8, and 9 into this box. And do we know what its nature is then? 12. It's adding up to 25, isn't it? That's no, 17. No, it's adding up to 24. Apologies. No, I've broken this. I've made a mistake, haven't I? There's something wrong. I've done something wrong. I don't know what it is. Because I really don't know what it is. What have I done wrong here? This is 12. 12 and 9 is 21. This adds up to 24. That means it should have 2 odd digits in it, which should be 9 and 3, and it doesn't have 9 and 3 in it. So, I don't know what I've done wrong there. I've got to go back. I have a horrible feeling it's whatever logic I did here involving... That was a 4. That was not an 8. I simply refuse to believe that was wrong. So this is a 4. These add up to 25. 25 and 4 is 29. These add up to 16. The even numbers in this... Oh, 16 is square! Oh, that's it. Wow, wow. I assumed it was the parity thing, but it's not. And now, well, I should have remembered I need to colour things in. So this is a square total. So I don't really know what it's got in it then. Oh, that's so ridiculous. I know it's got a 2 and a 5. Because 2 and 5 can't go in those cells. So there's a 2 and a 5 in there. And then 2 numbers that add up to 9 that are whatever is not used in here. Okay. 9. This is adding up, right, this is adding up to 24. So it has a 3 in it. Maybe so I can attack it from this side. Maybe that's how you're meant to do it. Because it's still true to say that's 9. 9 and 12 is 21. This has got to add to 24, which means its odd numbers add up to 12 and include a 9. So this has got 3 and 9 in it. And then we need 12, so we can't use the 8. So it's 2, 4 and 6. So now we're away, are we? Away. What a ludicrous way of describing where I'm up to in this puzzle. This is a 1, 8. I think that's not what I had last time, so this is better. So now there should be a 1, 8 down there, and we end up in this situation. And this one is one of the funny cages. So this really is a parity cage, so that should be blue. Oh no, where's all my numbers gone? Come back numbers, all is forgiven. Now this one is the one we don't know about, so I'm going to switch this one's colour to green now. Or do we know about it now? Do we know? No, we know it adds to 36, which it's like this one. It could be either way. And until I get more numbers in it, surely I'm not going to know. Oh, I'm so sorry, people. I'm sure that you're very frustrated with me. I'm very frustrated with myself here. I think that I'm not doing this puzzle justice at all. It's very clever, and I'm just not seeing the things I need to see nearly quickly enough. Now, okay, what do we look at next? We can. I know this is that domino adding up to 9, I think. Yes, I do. Oh, it's that. Yes, it's a 3, 6 pair. Aha! Use the numbers you've already got, Simon. That will help you more. 2, 4, 9 there, therefore. There's definitely a 3 and a 6 in that triple. So these digits in the rest of box 3 are 1s, 4s, 5s and 8s. I can't see how that's helping me. It can't be this cage or this box, can it? No, I know what it's going to be. I know what it's going to be. Good grief. Right, okay. I'm not sure that I couldn't have done this earlier. But look at those 4 digits there. Now we know. Oh no, we don't. Oh no. Oh no. I thought I knew something and I don't know it. I was about to get very excited by the fact that these cages are looking at 2 cages up here. So I was about to say, and it's true actually, that these cages can't be 3, 6 or 2, 7. Because obviously if that's 3, 6, this cell has no value. But the problem is that in this box there is a 16 cage, because this is a 2, so the 4 cages here are 16 and 3 9s. Now neither of those can be the 7. Right, I've rescued it. Where is the 16 cage in that box? This 9 rules it out of that one, and this 7 9 pair rules those out. So that's the 7 9 cage. And that means I can apply this logic. I think. Yes, I think I can. These cages here add up each individually to 9, and they are not 3, 6 or 4, 7. So this must be a 4, 5 and a 1, 8 combination, which means this must be a 3, 6 combination. It doesn't do anything. I don't believe it. I really don't believe it. What am I missing there? Oh, that's rotten. That is so unfortunate. Right, so 7 is down here now. 9 is in the middle box. It's in one of those squares. 7 is over here. Ah, 7 is in one of those two. Now this one might be more interesting because this is a 9, which means each one of these cages is adding up to 9, which means that if there's a 7 in one of there, there's a 2 in one of there, because one of these is a 7-2 cage. So this cage here is either 1-8 or 3-6, but I don't think we know which one. Well, we could use uniqueness. I would in a competition. That can't be 3-6, because if it was 3-6, it would make a deadly pattern with that 3-6, and there would be no internal logic in this puzzle that would determine whether the 3s were there and there, or whether they were there and there. So we will discover, I'm sure, that this is not 3-6. But I won't use uniqueness to solve the puzzle. So 2 has got to be in one of those cells, which means there's probably some reason why that can't be a 2-9 pair. Right, let's look at that. Is that a 2-9 pair? Then it's adding up to 11. Well, if that was a 2-9 pair, this can't be a parity cage, can it? Because we know that there must be 2 odd numbers in the cage in order to add up to the even number. And once 9 is one of the odd numbers, I can't put an even digit in high enough to add up to 10. So this would have to add up to, this would have to be 2-9, and then that would have to be a 5, because this would have to add up to 16, and that would work. Oh, bother. What else are we meant to do here? Can you lock 9 out of this one on the same basis then? Because if 9 is in there, this can't be a parity cage, so this would have to add up to 16. So these 2 cells here would have to add up to 7. So they'd have to be 1-6 or 3-4. Well, it looks okay, doesn't it? So hang on. Okay. This is very, very difficult. At least, no, I should caveat that. It's very, very difficult for me. Right. I see. I have understood this all of a sudden. The light has dawned. This is really clever. This is such beautiful setting, honestly. It's just too clever for me. Right, row 4. Look at this domino here. No, purple's a silly colour. I'll make it grey. This is a grey domino that adds up to 9. These are dominoes that add up to 9 that contain a 4-5 pair and a 1-8 pair. Therefore, how could this be a 4-5 pair or a 1-8 pair? It can't be. It would rule both of these vertical cages out from having that combination. So this cage is a 3-6 cage because it can't be a 2-7 cage. And now it's a 3-6 cage. I can rule 9 out of this cell. Because if this is a 9, these 2 cells have to add up to 7, and there is no way of making that work without 2, 5, 3, 4 or 1, 6. So that is not a 9, which means 9 is in this box, which means this box is a square box because it can't be a parity box, which means that this box adds up to 16 with a 9 in it. So this has 2 cells in it that add up to 7. So it's either 1, 6, 2, 5, 4, 3, 4, all of which are possible. I don't believe it. Please tell me this can't be a 2. If this is a 2... Oh no, the thing is, if this is a 2, This could be a parity cage again. If this is a 2, well, actually it's quite difficult for this to be a square cage if this is a 2, because this domino can't add up to 14, because 5, 9 and 8, 6 are not available. So right, okay, no, if this is a 2, this can't be a square cage at all, because it's either got to add up to 16 or 9, and 9 would require these two squares to be either a 1, 6 pair, which they can't be, or a 3, 4 pair, which they can't be. So if this is a 2, this is a parity cage. And that doesn't work, because the even digit has to be the sum of 2 odd digits. Oh, that's so clever. Right, so this is a 2, 9 pair. Wow. So this is 2, 9, and this was a square. We've worked that out. So this is 2, 5, 9. And that's not 9, I've just noticed from this little thing here. Oh yes, I see. This is a 5, therefore this is a 2, 9 pair. That's the point. So this is a 2, 9 pair. This is a 5, which doesn't do anything. Oh no, it does a bit actually, because now the 5 must overlap with the 7 in this box. So that's 5, 7, and this is 2, 4. And this 3, 6 means that's 1, 8. Doesn't do anything at the top. 5, 7 here removes 5 from those cells, so it removes 4 from these cells. I've now got a 1, 4, 8 triple look in this row, so this cell has to be 3 or 6. I'm trying to spot things, I promise. I've got a 2, 4 pair here. These squares seem to have all the options in the world. 1, 3, 6 and 8. Oh no. Oh, where does 4 go in this box now? By Sudoku it goes here. Oh, that should be good, shouldn't it? So 4 is off down here in column 6. Now what's that done to this? Right. Oh no. This could be 1, 3 pair. This could be a parity box if this is a 1, 3 pair. So 1 is an option. If it's not... yeah, this is good. If this is not a parity box, this has to add up to a square number. The numbers available are 9, which would require these two squares to add up to 5, but they can't, because they can't be 1, 4 and they can't be 2, 3. Or 16, which requires these two to add up to 12. They can't be 5, 7, they can't be 4, 8, and they can't be 3, 9. So this is a 1, this is a 3, and this is a blue box. And that means those cells are a 6, 8 pair, which means this is a 1. Come on. Come on, Simon. You are in with a little chance of finishing this, I think. That can't be 1. I should be able to. Yeah, 3s and 6s are resolved. So that's 3. That's 6. This is 14 so far. Who knows what that means for this domino down here? No doubt something incredibly devious. I think this is what we're going to have to look at though, isn't it? So, do we know the nature of this cage? We know that if this is a square cage, it's adding up to 25, because it can't be big enough to add up to 36, and it can't be small enough to add up to 16 once these two squares add up to 14. So if it adds up to 25, these two cells add up to 11, and they can't be 5, 6 or 3, 8. So this is either 4, 7 or 2, 9. And again, I can tell you by uniqueness, this is not going to be 2, 9. But I don't think, again, that's not going to be the way we have to do this. Now, the other option is that this is a parity cage, which means these two would both have to be odd and add up to 14. So this would have to be 5 and 9, and that would make this a 9, and that also looks possible. I don't believe it. I just don't believe it. It's so tricky. What about that? Do we know? Oh, we know that's a... right, hang on. I know something about this domino. Because this is a square number, and it's not 16, because 7, 9 is not available. So it's adding up to 9, and it's not 1, 8, 3, 6, or 4, 5. This is 2, 7. Which means that's a 9, and that's a 7. And that's not 2 anymore. So down, this is 5, 6, or 8. Ah, I see. Oh, this is beautiful. Good grief. Right. So now let's revisit this again. Because now I've done this puzzle in the wrong order. At every moment I've just got it wrong, haven't I? But look now, this cage is now not capable of, well, this domino is not capable of adding to 11. So this can't be a square cage. Because it can't add to 11 because 2, 9, 3, 8, 4, 7 and 5, 6 are not available. So this cage is a blue parity cage, which means that these squares have to be a 5, 9 pair. And that's 5 and that's 9. And that's 9 and that's 2. And that means we've got 1, 8 here, which makes this a 5 and this a 2. And that's not 5 anymore. Now, come on. Maybe we have to look at this column because we've got 6 digits in effect. We need 3s, 4s and 6s down here. Now, what's the nature of this cage? I feel like I've asked that question a lot. Well, if this is a... oh no, it could be a parity cage again. If that's got a 4 in it... oh, it does have a 4 in it, in fact. So if it's a parity cage, that's a 1, and that looks plausible. If, on the other hand, it's a square cage, it can't add up to 9, because that would have to be 4, 3 here, and that would put 2 here. So it would have to add up to 16, which doesn't work. Good grief, this is so intricate, it doesn't work again. Right, so if this is a square cage, it can't add up to 9. The reason it can't add up to 16 is because we know there's a 4 in it. The other 2 cells in it have to add up to 12. If there's a 6 here, that would put a 6 here and repeat in the cage and the column. If there's a 3 here, that puts a 9 here and that repeats in the column. So this is a parity cage, which means it's blue. It means that there's a 4, 3 and a 1 in it. So that's not got a 6 in it, which means that's a 6 at the top and that's a 3. This 1 rules itself out of these cells. Now, what does that mean? So that means that these squares here have got to be from 6. Oh, have I missed a digit out? Oh no, where does 1 go in this box? That's a sensible question. 1 goes there. This is a 6 or an 8. So 1 must be up here in box number 7. I'm laughing because, you know, you can almost sense it's going to be this cage. Somehow, some way, that cage is only going to have one option. And it just looks so uninviting to try and work out how that can possibly be true. Right. Let's have a think about this. If this is a parity cage, we know its even digit is this one. So these would have to be 2 odd digits. Now, yeah, okay, so if this is 6, that would require 1, 5, which is broken. If this is 8, it requires 1, 7 or 3, 5, which are both broken. So somehow or other, that is a square cage. Now, it can't add up to 9 because we can't put 1, 2 in here with a 6 there. So it does add up to 16. Now, if this is a 6, that doesn't work. You can't make this domino add up to 10 because the 6 would repeat with a 4, 6, 1, 9, 2, 8 and 3, 7 are all unavailable. So that I think, is an 8. So that gives us an 8 and a 6. And a 6 here. This domino adds up to 8 now, and it's not 1. So this is a 2-6 pair, which means that's a 6 and that's a 2, which resolves the 2 and the 7. Puts a 2 over there in that cage, which is somehow going to work magic over there, I bet you. These squares are not 2 and 6. This is a 3 or a 4. Oh, a 3-4 pair now in the bottom row out of nowhere. It's very odd as well. Look how much real estate is unfilled in the top. It's sort of columns 1 and 2 and columns 8 and 9. The answer to that is a lot. 6 has to be down here in box 9. Wow, okay. Sorry, I'm just staring at this in the hope that the sort of light dawns. Oh, okay. Right. I think that was a sensible thought to say, how could there possibly be so much in these columns unfilled? That seems to have to be a 1, 4, 5, 8 quadruple, doesn't it? So that means this square is not capable of being a 4. So that must be a 3. And this must be a 2-6 pair now, which means that this has become a 4-9 pair, which means that that's not a 4. Oh, something's wrong here. No, that 5 is giving me an 8 here. That's not wrong yet. Okay. So that gives me an 8 here and a 1 here by Sudoku. No, it's not done it. I suppose that's a 4 down there. Maybe this is what does it. 4, 3. 4 is in one of these cells. No. Is there some reason this can't be a 2? Oh, if this couldn't be a 2-4 pair, that would put the 4 here, and that would do some work up there. Right. Okay. Let's study this cage then. Actually, I just want to check what's missing from this column. 4, 5s, and 7s. So these are 4s, 5s, or 7s, and that's not 5, and that's not 4. No, I'm not seeing what that does. Okay, so what is the nature of this cage? If it was a 2-4 pair in it, this would have to be a 3. And that's incredibly annoying because that looks possible to me. Because the reason I say that is if it's got 2 even numbers in it, it can't have 2 odd numbers, which is what it would require to be a parity cage. So it would have to be a square cage. You can't write 10 into that cell. So the only way of working this would be that this adds up to 9. This would be a 3. That would seem to do some magic. So maybe that's correct then. So we know there's a 2 in there. So I suppose that, okay, so that's what we're going to have to ask. What happens if there is no 4 in there? So if the 4 is here and this has got a 2 in it, then, well, I suppose then it can't be a parity cage because we can't make 2 odd numbers add up to 2. We can't repeat double 1 in this box. In fact, it would be treble 1. So if there is a 2 in here but no 4, it needs to be a square cage. Now it can't add up to... No, it can't. It can't add up to 16 in that case because I can't put 14 in here. This would be a 5, 9 here, ruling out 5 and 9 from that domino. So you can't make this a Schrödinger cell and simultaneously be 5 and 9 at the same time. And you can't put 6 in the cage at all. So this has to add up to 9. So if it has to add up to 9 in the case where 4 is not in it, it would have to have... No, it can't. It can't. It just doesn't work. Ah, this is ridiculously intricate. Honestly, I think I'm being very slow today, but I'm going to be interested in the comments because I don't think this is a simple puzzle, actually. So this cage has to, I think, be a 2, 4, and a 3. I'm not sure of the order of the 2 and the 4, because if the 4 is not in it, there is no way to make it add up to 9. Because we need a domino in there, we need 2 of the cells in it to add up to 7, and 2, 5 is not available without repeating the 2, 1, 6 isn't available, and we've said the 4 isn't in it, so 3, 4 isn't available. So this has to be, it has to have a 4 in it, which means that's a 7, means that's a 5, that's a 4, and because this is a 2, 4, we need this to be a square, so this has got to be a 3, which makes that a 3 and that a 6, that a 6 at the bottom of the grid. This is a 2, 4 pair. Now what are those squares then? 8s and... oh, I don't believe it. 8 and 9 is not resolved. How can this not be resolved? How? So this is 7, 8 and 9 over here. This row, look, needs 1 and 3 into those cells. This is okay, well, I suppose I've still got one cage left, which has got a lot of... So this one cage is going to resolve the whole of the rest of the grid. That does not seem likely to me. I am fearful. Right, 5, 8, 9 into these squares. So, what is the nature of this cage? We'll award this cage purple while we think about it. Oh, that cage was a square number, wasn't it? So that's getting oranged. This cage, well, it's odd digits, its even digits add up to 18, and its odd digits add up to 18. So it's a 2. This is both. This is a both coloured cage. Oh, that's rather cool. I'm glad there was a cage like that. So this cage has 2 personalities. Always reminds me of the chant the Rangers fans used to shout at their goalkeeper, who suffered from schizophrenia but had quite a sense of humour about it. So they weren't being malicious, but they used to shout, "There's only 2 Andy Gorhams." Only 2 Andy Gorhams, 2 Andy Gorhams, which is the wit of a football fan. Right, now, how do we do this then? I'm sort of putting it off because I can't see immediately how to do it. Right, let's say that this is a parity cage. If it's a parity cage, it must have 2 even numbers in it, which would have to be 4 and 8. So it would have to be 4 and 8, and 4 and 8 would have to add up to 5 and 7. So one option here is that this is 4, 8, 5, 7. I'm just trying to see why that doesn't work. 4, 8, 5, 7. I don't know why that doesn't work. That would be a 5. That would actually, I could see how if that was correct, it would disambiguate a lot of columns 1 and 2. So hopefully we will be able to show that this cannot add up to a square number. Now, what square numbers are available given the digits? We cannot have 16 this time, because the minimum value of those 2 squares is 15 already. So we must be adding up to 25, which means these 3 squares must be adding up to 21, and that's possible with 9, 5, and 7. I don't believe it. Okay, well the only thing I'm seeing there is that this cage always has 5 and 7 in it. Is there another way of making 21? No, 6, 7, 8 is not available, so we have to use the 9. We need 2 digits to add up to 12. The only other things available are 5 and 7 with the 9. So, this purple cage is either 4, 8, 5, 7, or it's 4, 9, 5, 7. So there's definitely 5 and 7 in it. That square's not 5. Now that means that we've got an 8, 9 pair in this row, and that's a 5, which makes that 5, and that's 7, and that's 7. Oh no. No. This is deadly, isn't it? Isn't this a deadly pattern? I've got a bad feeling I've done all this work and it's for nothing. What on earth am I meant to do with this? 7's a result? 5. Oh no, I know what it is. Now I've got the cages, of course. So the implications of the 5, 7's getting resolved is that these cages get resolved, and that's going to do work. So that's a 4 and that's a 2. So that's a 2 and that's a 6. So that's a 6 and that's a 3. That's a 3 and that's a 1. That's a 1 and that's an 8. 8, 9. Oh, and that's coming over here. Oh, that's ridiculous. That is ridiculous. Look at it. Look at it. I think I've done it. I don't quite know how. So what was this cage in the end? This was 20. This was a square. This was a square cage. Yes. Oh my goodness me. I'm so sorry that took me such a long time. I was very, very bamboozled by that, as you no doubt noticed. Something of a movie length edition today. I need to go and, I don't know, drink some gin and tonics or something to repower my brain. There must have been a better way of doing this, I think. Mind you, I will say ambiguity puzzles are notoriously hard. This does have, I think, 5 stars out of 5 for difficulty on Logic Masters Germany, according to the testers. So I think it is meant to be a difficult puzzle. But that's no excuse, really. I mean, there's some beautiful logic in this. The whole idea around the top of the grid and this shape of this cage, and this being a virtual 9-cell region, and then those cells having to be the same, and then the fact that you could use that to sort of pinpoint the value, or at least reduce the options for this cell. I mean, that is quite, well, it took me ages to see it, but it's quite complicated stuff. But the thing I really struggled with, actually, was I got this cage down to just a few options, but I could not for the life of me see how to figure out how these 2 boxes work. Well, I mean, I figured it out for the life of me in the end, but it almost took me my whole life. So apologies for that. I hope you forgive me. I hope we'll see you later and I haven't bored you to tears. And we'll be back later with another edition of Cracking the Cryptic.